Yes, class. Hope everyone is fine. Today we are going to continue our 12th lesson, and the topic is structure and bonding. And today we are going to consider two subtopics. The first one is Ionic structure, and the second one is covalent bond. Now remember that whatever it is that we are going to deal with in this topic is that the ion form is having an intention of having what we call stability. And stability can only be achieved by either having a duplet state or an octet state. Now, we have seen how ionic structures are formed, and I just want to talk about some few examples too. Some more few examples. Suppose a situation whereby we are having calcium oxide, or let us talk about beryllium oxide. Beryllium oxide. So beryllium has got 2,2. Oxygen 2,6. Now, for this one to be stable, beryllium to be stable, it needs to lose these 2 electrons for it to be stable. At the same time, oxygen needs that stability by gaining 2 electrons. So the 2 electrons will be lost and gained on this side. What I want to have is beryllium with the 2 electrons, the 2 positive, while oxygen will gain the 2 electrons from beryllium, which will come this structure. So then this one, beryllium, will be an ion with 2, while oxygen will also be an ion here with 2 H. Now these 2 X's send up. Now suppose so you see in the cases we considered, we have sodium, or rather we have an atom which loses 1 and the other one loses 1. And in this case, this atom loses 2 electrons and this one loses 2 electrons. But now we want to consider a case whereby an atom needs to lose 2 while the one which is gaining needs to lose 1. And we are also going to consider where an atom needs to gain 1 and the one losing going to give 2. For example, let's talk about sodium oxide. So sodium, let's talk about sodium has got 2, 8, 11, 2, 8, 1, sorry. Plus oxygen, 2, 6. Now, this sodium, 281, or this one is oxygen, 2,6. Now, if you look at sodium here, sodium needs to lose 1, while oxygen needs to gain 2 in order to be stable. Sodium needs to lose only 1 for it to be stable, but this one needs 2. So should we release just this one here? This oxygen is going to end up with 2,7 instead of 2,8. So what do we do? That means we need 2 of sodium, such that one sodium loses 1 electron to come here, another sodium loses another electron to come here. So what do you do? You multiply here by 2. So that if you multiply by 2, that means we want to have 2 sodium atoms. One will lose 1 electron to come here, and another one will also lose another electron. So that's what we're going to end up with. Sodium after losing those 2 electrons, remember there are 2 of them. We put 2 outside. Then positive. Then oxygen, after 2 sodium atoms have lost 2 electrons, they are going to end up with something like this. This one is. So, end up with sodium plus 2H, 1 oxygen, 2H. Now, this is a case whereby the losing species is supposed to lose 2, sorry, it's supposed to lose 1, while the species receiving is supposed to receive 2. The one which is losing 1. It's only capable of losing a maximum of 1. But the one receiving needs 2. So you have to multiply this one by 2, so that 2 of this one loses. Now we want to consider whereby the one giving is supposed to give 2, while the one receiving is supposed to receive only 1. We want to consider a case whereby the one giving is supposed to give 2, but the one receiving is supposed to receive only 1. What do we do now? For example, beryllium fluoride. Beryllium fluoride. Beryllium is supposed to give 2 electrons. Now, beryllium is supposed to give 2 electrons, but fluorine One, 2, 3, 4, 5, 6, 7. Now, beryllium has got 2 electrons to give. Beryllium has got 2 electrons to give. Well, fluorine can only receive 1 electron. We just need 1 electron to be stable. But beryllium can give 2. How do you handle such kind of case? So what we are going to do, beryllium will give 2. So what we do, we just multiply fluorine by 2. Such that the 2 of fluorine each will get an electron from beryllium. So beryllium, after losing these 2, will become beryllium positive 2. While fluorine, after receiving these 2, but there are 2 of them. Let's put 2 there. So when you put 2, it means 2 of these fluoride ions, or rather fluorine atom, each will get 1 from beryllium to be like that. Now, so let's look at what we call giant ionic structure. Ionic structure. Those are my examples which are not drawn on the board. You can look at them and have more insight. Now, when you talk about giant ionic structure, you find that an example is sodium chloride. Sodium chloride is made up of sodium and chlorine ion. And we find that each chloride ion will be surrounded by 6 sodium ions. At the same time, this sodium ion will be surrounded by 6 chloride ions. And the pattern will repeat itself until what we are going to form is what we call giant ionic structure. A structure like this one. So you find that each sodium ion is surrounded by 6 chloride ions, and each chloride ion is surrounded by 6 sodium ions. So other examples of such one are potassium nitrate, sodium iodide, potassium bromide, calcium nitrate. So we are going to take a break at this point, and when we come back, we are going to